Okay, so we're wanting to look at sum and difference identities for tangent. Um, so first let's start off by looking at tangent A plus B. And you know that the first thing that we always do is expand it. We know that tangent is always represented as sine A over cosine A, and so when we're adding it, it can also be tangent A plus B can be sine A plus B over cosine A plus B. The next step we need to do is expand those sum and difference identities out, which they're both sum identities. So sine is sine A cosine B plus cosine A sine B over cosine A cosine B minus sine A sine B. This is just proving where we get the formulas for tangent A plus B or tangent A minus B. We'll work through the sum identity. So the next step in this identity would be to multiply the top and the bottom by 1 over cosine A cosine B. We're doing this because eventually we want to get the identity into terms of tangent. And so if we do that, we'll be able to cancel cosines out, or we'll have sine A over cosine A, something like that, that will equal a tangent. So once we multiply them in, we get what looks like a lot of fractions on top of a lot of fractions. It's sine A cosine B over cosine A cosine B plus cosine A sine B over cosine A cosine B, all divided by cosine A cosine B over cosine A cosine B minus sine A sine B over cosine A cosine B. So what do we need to do? We need to figure out what can we cancel here. So the next thing we're going to do is look and see, okay, cosine B over cosine B will cancel, cosine A over cosine A will cancel, and then look at the denominator. You have cosine A cosine B over cosine A cosine B. We know that anything over itself is 1, so automatically we know that that cancels to 1. So then we have a bunch of sine over cosines, and automatically we think to ourselves, those can go ahead and revert back to tangents. And so looking at that, our identity, tangent of A plus B, is equal to tangent A plus tangent B, all divided by 1 minus tangent A tangent B. Now this is really important only because this shows us where we get the sum and difference identities for tangent. Those formulas are right here, and they're on your packet. So that's what we have. So let's look at our first example. The first example is tangent of 30 degrees plus the tangent of 15 degrees is divided by 1 minus tangent 30 degrees, tangent of 15 degrees equals what? What this question is really wanting us to do is to simplify it. So all we have to do is look and see what's our first angle, what's our second angle, and put it back into the sum identity. And that would be tangent of 30 degrees plus 15 degrees. We all know that that would be the tangent of 45 degrees, but we're not actually going to use that in this way. We're just going to leave it how it is, because on a unit circle we could find the value of tangent of 40 degrees. We're just using these numbers because they're easy to use as an example. So for example number 2, we're given the values of tangent A, which is 1/3, and tangent B, which is 1/2. And it asks us to find tangent A plus tangent B. So let's start with the sum identity for tangent. Tangent A plus tangent B. Well, automatically we need to go ahead and write out the formula. Tangent A plus tangent B, all divided by 1 minus tangent A times tangent B. Then we can start filling in with the fractions. We know that tangent A is equal to 1/3 and tangent B is equal to 1/2. So if we replace those in the formula, we get 1/3 plus 1/2, all divided by 1 minus 1/3 times 1/2. And then all we have to do is simple math. Looking at that, we have to get a common denominator to be able to add those fractions. And that common denominator would be 6. So we have 2/6 plus 3/6, all divided by 1 minus 1/6. If we continue with our math, 2 plus 3 is 5, so it's 5/6. Over 1 whole minus 1/6 would be 5/6 as well. And so 5/6 over 5/6 is equal to 1. So the tangent of A plus B is equal to 1. Now what about the difference? Tangent of A minus B. Well, if you write the formulas out, you'll notice that tangent of A minus B, the only difference for its formula is that we have a positive and negative on top and bottom actually switch out. So the formula is tangent A minus tangent B, all divided by 1 plus tangent A times tangent B. Work the same math out. We have 2 divided by 6 minus 3 divided by 6, all over 1 plus 1/6. So that equals negative 1/6 over 7/6. So we have two fractions, and we know from our lovely saying, dividing fractions is easy as pie. Flip the second and multiply. We flip the bottom fraction to be 6 over 7, and we're going to multiply. So we have negative 1/6 times 6 over 7. We can cancel out the 6's, and that would give us negative 1 over 7, and that would be our answer for the difference identity of tangent. So now we're going to look at example 3. Example 3 says, if pi divided by 2 is less than alpha, which is less than pi, which is less than beta, and that is less than 3 pi divided by 2, and the cosine of alpha is equal to negative 3/5, and the tangent of beta is equal to 12/5, find the sum and identities for sine, cosine, and tangent. So we're going to go ahead and start by looking at what the triangles, the reference triangles, would look like on a coordinate grid. Now, I already have them drawn out for you. When it tells us pi divided by 2 is less than alpha, which is less than pi, that's telling us that alpha is in the second quadrant. So that's why we have alpha drawn there. We know that the adjacent to that angle is going to be negative 3. The opposite side of that angle is going to be 4. And the hypotenuse is going to be positive 5. Then when it tells us that pi is less than beta, which is less than 3 pi divided by 2, we know that's telling us that beta is in the third quadrant, so that's why it's drawn there. And in the third quadrant, your x value is negative and your y value is negative. So our adjacent value is negative 5. Our opposite value is negative 12 because it tells us that tangent of beta is 12 divided by 5. That's opposite over adjacent. And because it's positive, both of them are negative. If you have a negative over a negative, that leaves us with a positive. And from Pythagorean theorem, we could find that the hypotenuse is 13. So now we're going to look at the sum and difference identities for sine. If you go ahead and write out the formulas, sine alpha times cosine beta plus cosine alpha sine beta is the formula for the addition. For the subtraction, you have sine alpha cosine beta minus cosine alpha sine beta. From that, we just start filling in our fractions. The sine of alpha is 4/5. The cosine of beta is negative 5 over 13, plus the cosine of alpha, which is negative 3 over 5, times the sine of beta, which is negative 12 over 13. Do your math, multiply in. You have negative 20 over 65. Plus 36 over 65, so that would give us 16 over 65. And the difference between the sum identity and the difference identity is addition and subtraction. So if you just go ahead and take the bottom equation and you change it from addition to subtraction, you can have your difference identity pretty quick. So it's negative 20 minus 36, which would be negative 56, and then of course our bottoms don't change for a fraction, so it's 65. Now if we look at the cosine sum and difference identities, we can write them out. The sum identity is cosine alpha cosine beta minus sine alpha sine beta. The difference identity is cosine alpha cosine beta plus sine alpha sine beta. That'll give us each one. And again, if you'll notice, the difference between the two identities is either it's a subtraction problem or it's an addition problem. So once we work it down, we can just switch the signs or switch the operators. So if we go ahead and plug in those fractions that we know we've already plugged in, we've already used, we would have 15 over 65 minus a negative 48 over 65. That's equal to 63 over 65. That's for the sum identity. And then for the difference identity, we would have 15 over 65 plus a negative 48 over 65, and that would give us a negative 33 over 65. Those are pretty much reviews from Wednesday. Then if we look at our tangent sum and difference, again, the difference between those two identities are the operators. One has addition on the top and subtraction on the bottom. The other one has subtraction on the top, addition on the bottom. So we'll just fill in what we know. We have a negative 4/3 plus 12/5 over 1 minus a negative 4/3 times 12/5 for this sum identity of tangent. If we go ahead and get common denominators and work that all out, we have negative 20 over 15 plus 36 over 15, all divided by 1 minus a negative 48 over 15. So our result would be 16 over 15, all divided by 63 over 15. Again, our fun saying, dividing fractions is easy as pie. Flip the second and multiply. So we're flipping the bottom fraction. So we'd have 16 over 15 times 15 over 63. Multiply straight across. The 15's cancel to be 1. So we have 16 over 63. Now, the difference identity will be the exact same thing, except we're going to change the top to subtraction, the bottom to addition. So if you want to go ahead and change from the point where we found the common denominators, you can. So it would be negative 20 over 15 minus 36 over 15. And then that's all divided by 1 plus a negative 48 over 15. Your two fractions that you end up with would be negative 56 over 15, all divided by negative 33 over 15. Flip the fractions, multiply. Negative 56 over 15 times 15 over negative 33. Here the 15's cancel to be 1. The negatives would also cancel each other out. So you'd have 56 over 33. And that, my friends, is the sum and difference identity of tangent. I hope y'all are enjoying your time. I hope to see you on Monday. Please don't forget to send me any of your missing assignments because Friday is the end of the 3 weeks. Bye.